All right, buckle up for another deep dive with us. Today we're going deep into the world of asphyxia.
Asphyxia.
It's a topic that we've kind of touched on here and there, but we've got some new research articles, autopsy reports, even some case studies that we're going to
Yeah, we can really dig in
dig
today.
into. I think it's going to be a
Yeah.
really fascinating deep dive. Now, a lot of people, they hear asphyxia
Yeah.
and they think, oh, that's suffocation.
Right. Or they just think about like the classic signs, like
Right.
blue skin and petechiae, things like that.
Yeah, exactly. It's like what we see on TV.
Exactly.
But I think today we're really going to uncover
Mm.
some nuances that people might not realize when it comes to asphyxia.
Yeah, it's a lot more complicated than people realize. And actually, to start off, one of the things that's really important to remember is that asphyxia itself isn't a cause of death.
Oh, okay.
It's a mechanism.
A mechanism. So
Yeah.
so explain that.
So it's all about the failure to get oxygen to the body. And there's like lots of different ways that can happen. So like environmental factors,
Right.
like being trapped in a place without enough oxygen, or
Yeah.
choking, strangulation, even certain diseases. They can all cause asphyxia.
Sounds like an
That's kind of this umbrella term.
umbrella term.
Yeah.
Yeah.
Okay.
And what we're focusing on in this deep dive is what we call mechanical asphyxia,
Hmm.
where external forces are involved. And that's really interesting from a forensic point of view. Like how did that
Right.
oxygen deprivation actually happen?
Right. Because you have to find the clues.
Exactly.
So you mentioned, like what we see on TV.
Yeah.
Blue skin petechiae. Are you saying those aren't always?
Those are not always reliable indicators.
Okay, why not?
So take petechiae, for instance. Like they show that on TV as like a guaranteed sign of asphyxia, but it turns out they can actually be caused.
A lot of different things, like even sudden heart attacks.
Right.
Or even just things that happen
Yeah.
after death, normal processes.
So you're saying,
Yeah, so you can get petechiae.
hold on, you're saying petechiae can appear after death.
Yeah, it's called the Prinsloo and Gordon artifact.
Wow.
It really it challenges our
It's
assumptions.
how we think about it. Yeah, that's fascinating.
Yeah.
So if those classic signs like the petechiae aren't always reliable, what are forensic pathologists looking for?
Well, let's take drowning as an example.
Okay.
You find a body in the water. Seems obvious, right? They drowned.
Right.
But it might not be that simple.
You're saying,
What if they had like a heart attack while they were swimming?
right.
Or were injured before going in the water? You have to consider all those possibilities.
Yeah. But what about like the physical signs? You hear about washerwoman's hands.
Right, washwoman's skin.
Yeah.
Yeah, so that's when, when you're in the water a long time,
Hmm.
your skin gets all wrinkly and pale, and you see it, especially in places like the palms of the hands and the soles of the feet.
Okay.
And it does show that the body's been submerged, but it doesn't necessarily mean they drowned.
So we can't
Which
just
goes
assume the
down so-
puzzle. We need more information.
Exactly.
So what else would a forensic pathologist?
So they would be looking at, how does drowning actually happen? What are the mechanisms?
Yep.
And actually how we understand drowning has changed over time. Like at first, people thought it was just suffocation, like the water just fills up your lungs. And then there was a lot of focus on electrolyte imbalances, especially with fresh water.
Electrolyte imbalances.
Yeah. So like
So like if you're dehydrated.
similar concept, but it's the concentration of salts in your body getting messed up by the water.
Right.
But now we kind of come back to hypoxia as like
Yeah.
the key problem.
So it's more,
Thing.
there's water in the lungs.
Yeah.
See?
More complicated.
Exactly. It's a really complex biological process.
So if we're talking about drowning, and we know that those classic signs like petechiae aren't always reliable, what would a forensic pathologist be looking at specifically during an autopsy?
So there are a few key things. Like one thing is froth.
A froth,
Yeah.
like on a cappuccino?
Well, not exactly,
Yeah.
but it's this mixture of water, air, and mucus.
Hmm.
And it forms because the airways are irritated and
They
there's
stink.
fluid. But here's the thing. Froth isn't always there.
Oh, okay.
And it can happen in other conditions too, so it's not a sure thing.
So froth is
Yeah, it's a maybe.
a maybe.
Then you often see in drowning victims, their lungs are overinflated.
Okay.
So they get all filled up with water and the air gets trapped behind that froth.
Gotcha.
And these overinflated lungs, they're heavy, they're spongy. They can even have like indentations from the ribs.
Wow. So it's not just water, it's
Charles
the air
Dickens.
getting trapped. And then there's another thing. You might find diatoms.
Diatoms.
Yeah.
Now, remind me what those are again.
So diatoms are these tiny little algae. They've got these hard shells made of silica,
Okay.
and they're found in pretty much every water source. So if someone drowns, they inhale water with these diatoms in it, and those diatoms can actually travel through the bloodstream to other organs, like even the brain or the kidneys.
Wow.
So finding diatoms can be a clue that the person was alive when they went into the water.
So it's almost like a microscopic
Fingerprints.
saying
Yeah.
you were here.
Exactly.
Wow.
But it's not perfect. Diatoms are everywhere, right? Like even in the food we eat. So just because they're there doesn't automatically mean drowning. It's just one more piece,
Wow.
a very complex puzzle.
Okay, so we're just scratching the surface here, but it's
Yeah.
clear that drowning is a lot more complicated than we might think.
Yeah. And there's a whole world of other ways that asphyxia can happen. So let's move on to strangulation,
Okay,
because that's where it gets a little bit darker
Oh, you're to
and
the
more
front.
complex.
go there.
Welcome back to our deep dive on asphyxia. So we've talked about drowning. We've talked about some of the intricacies of that.
Yeah, it's fascinating and kind of disturbing at the same time, right?
Yeah, definitely. But there's, all these other ways that asphyxia can happen that we need to talk about.
Okay, so what's next?
Let's talk about positional asphyxia.
Positional asphyxia.
Yeah.
Okay.
This is where someone dies just because of how their body is positioned.
Wait, what?
Yeah, you heard that right.
Seriously? You can die just from how you're positioned.
It sounds crazy,
That's...
but it happens.
Wow.
So it's like external pressure or sometimes even just gravity restricts their breathing.
Okay, I kind of see
Yeah.
how that could be dangerous. But what are some examples of that? Like, how would that actually happen?
So think about someone being crushed under something heavy
Okay, yeah.
or trapped in a tight space.
Right.
You know those awful stories about people trapped in collapsed buildings or like industrial accidents?
Like,
Even being hogtied, like face down, can put enough pressure on your chest and abdomen to stop you from breathing properly.
so you're good.
It's not just about being uncomfortable. It's
Well,
like
it's
you
just-
literally can't get air in.
You can't breathe.
Yeah.
Wow. That's scary.
And then on top of that, there's often other things going on that make it worse.
Like what?
Like if someone's been drinking or using drugs.
Oh, right.
That can make it even harder to breathe and harder to get out of that dangerous position.
So you've got this, like, double whammy. You can't breathe because of the position you're in, and then you're also intoxicated.
Yeah, it's a recipe for disaster.
Yeah.
And the thing is, there might not be any obvious signs of assault or anything, so
Right.
it can be hard to tell what happened.
So what are the clues then? Like, what would make investigators think, hey, maybe this is positional asphyxia?
Well, the position of the body, obviously.
Okay, yeah.
If they're in some weird, contorted position or there's signs of struggle or it looks like they were trapped somehow, that's a big red flag.
So it's not just about the position.
It's the whole story, right?
Yeah, the whole picture.
The context. And then there's another clue. It's called postmortem hypostasis.
Hypostasis?
Yeah, have you heard of that?
I don't think so. What is that?
So it's basically just the discoloration of the skin that happens after death. Like it turns kind of reddish purple.
Oh, yeah, I've seen that.
It's just from blood settling
Okay.
in the lowest parts of the body.
Gotcha.
But here's the thing. The pattern of that discoloration
Okay.
can tell you what position the body was in after death.
Oh, really?
Yeah. So like if they were lying face down,
Mm-hmm.
the hypostasis would be on their chest and stomach.
Yeah.
If they were hanging upside down, it would be in their head and face.
Wow. It's like a little map.
Yeah, that's so interesting.
Yeah.
Okay, so that's positional asphyxia, where like your own body.
Yeah. Like your body's the weapon.
Yeah. So what other
Very wild.
crazy ways can this happen?
So there's another one called restraint asphyxia.
Restraint asphyxia.
Yeah.
Okay.
This is when someone's restrained in a way that compresses their chest and abdomen
Okay.
so they can't breathe.
But isn't restraint just like holding someone back? Like how would that stop them from breathing?
So you're right. Being restrained doesn't automatically mean you can't breathe.
Right.
It's more about how they're restrained, the position they're in,
Yeah.
and the pressure that creates.
So like being pinned face down.
Exactly. Like if someone's being arrested or security guards are trying to control someone, or even in healthcare settings sometimes, if someone's really agitated, if they're held face down on the ground or against something hard,
Yeah.
that can really restrict their breathing.
Mm-hmm.
Oh, I can see how that would be dangerous.
Yeah, and it can be really hard to tell what happened in these cases.
Yeah, I bet.
Like, was it the restraint itself that killed them?
Right.
Or was something else going on?
Like a medical problem or something.
People who are being restrained are often really agitated.
Right.
And that can be from drugs, mental health issues, all sorts of things.
Yeah.
And that agitation can cause all these physical changes. Their heart rate goes up, their adrenaline's pumping, and that can lead to serious heart
So
problems.
it's like, did they die from not being able to breathe, or did they die from a heart attack?
Yeah, and the physical exertion of being restrained can make any underlying heart conditions worse. So it's really hard to
Yeah.
untangle all those factors.
Wow. So how do investigators figure that out? Like, if it's restraint asphyxia, what are they looking for?
Because they have to be really thorough, you know?
Yeah.
They look at the scene, the position of the body,
Mm.
any restraints that were used, any signs of a struggle.
So again, it's kind of like that positional asphyxia thing where you need to look at the whole context.
Exactly.
Uh,
And then during the autopsy, they'll be looking for signs of asphyxia specifically, like those petechiae we talked about earlier.
Petechiae, right? Those tiny little blood spots.
Yeah, they happen because tiny blood vessels burst,
Okay,
usually from increased pressure in the head and neck.
gotcha.
So in restraint asphyxia, the pressure from being held down could cause petechiae.
Oh, okay.
But they can also happen in other situations, like sudden cardiac death, so it's not a slam dunk.
So petechiae are a maybe?
Yeah, just another piece of the puzzle.
All right.
And then they'll look at the internal organs, see if there's damage that matches up with asphyxia, like are the lungs congested,
Okay.
any bleeding in the heart or other organs.
Right. And I'm guessing toxicology tests would be important too, right?
Oh, absolutely.
To see if drugs or alcohol played a role.
You got to know if they were on anything that could have made them more agitated, or if they had a heart condition, or if any medications were involved.
Right. It's all connected.
It all adds up.
Wow. It's really like detective work, isn't it?
It is. And these restraint asphyxia cases, they can be really controversial, especially when the police are involved.
Right. Because then you have the whole question of excessive force.
Exactly. So you need to be really careful and objective. It's not just about the science. It's about the legal and ethical implications, too.
Okay, so we've covered some pretty heavy stuff here.
Yeah, no kidding.
Can we maybe lighten things up a bit and go back to drowning? We talked about it earlier, but I'm curious about, like, the actual process of what happens when someone drowns.
Sure. Let's dive back in.
Okay?
Drowning might seem simple on the surface,
Right.
but it's actually really complex. It's not just about water filling up your lungs. It's about the whole process of oxygen deprivation.
Okay, so walk me through it. What happens step by step?
So first, there's that panic, that struggle to breathe, right?
And as water starts getting into your airway,
Mm-hmm.
your vocal cords slam shut. It's called laryngospasm.
Laryngospasm. So that's like your body trying to protect itself.
Exactly, trying to keep the water out. But that can't last forever.
Yeah.
You need oxygen. So eventually those vocal cords relax, and that's when the water really rushes in.
And that's when it gets really bad.
Yeah, because now your lungs are filling up with water.
Okay.
And that messes up the balance of oxygen and carbon dioxide in your blood.
Right.
And that leads to hypoxia, which is basically a lack of oxygen getting to your organs.
So it's not just that there's water in the lungs, it's that the rest of your body isn't getting oxygen.
Exactly. And that sets off this whole chain reaction.
Oh, wow.
Your heart can't pump blood properly.
Right.
Your organs start shutting down. And if you don't get oxygen back, you die.
It's a domino effect.
It is.
Wow. And I'm guessing it all happens pretty quickly.
It can, especially in cold water.
Oh, yeah. Why is that? Well, the cold water can trigger this gasp reflex where you basically inhale a huge gulp of water.
Oh, no.
So that just speeds up the whole process.
That makes sense. So are there different types of drowning? Like, does it matter if it's fresh water or salt water?
Yeah, we usually talk about freshwater drowning and saltwater drowning.
Okay.
And while they both lead to the same end, the way they happen is a little different.
Okay, so explain the difference. Like, what's going on in your body?
So in freshwater drowning, the water that gets into your lungs has a lower concentration of salts than your blood.
Okay.
And that causes water to move from your lungs into your bloodstream.
Oh, so it's almost like diluting your blood.
Yeah, and that can mess with your electrolytes, those important minerals your body needs.
Right.
And that can affect your heart and make things even worse.
So it's not just about the lack of oxygen, it's about this whole chemical imbalance too.
Exactly. Now, with saltwater drowning, it's kind of the opposite.
Okay.
The salt water has a higher concentration of salts than your blood. So water moves from your bloodstream into your lungs, and that causes fluid to build up in your lungs.
Oh, that doesn't sound good.
Yeah, it's called pulmonary edema.
Pulmonary edema. Okay.
So in both cases, your lungs end up filled with fluid, but the way it gets there is different.
That's interesting. So you would think saltwater drowning would be worse
You'd think so, right?
because you always hear about, like, the ocean being so dangerous.
Yeah, but it's not really about the type of water. It's about how long you're submerged and how severe the lack of oxygen is.
Okay, that makes sense. So we've talked about the mechanisms of drowning, but how do you actually diagnose it? Like, what would a forensic pathologist be looking for?
Well, there's no one single test that screams drowning.
Really?
It's more about ruling out other possibilities.
So it's a process of elimination.
Kind of. But there are some clues that can point in the right direction.
Like what?
Like we talked about before, that froth in the airways around the mouth and nose.
Right.
That's common in drowning, but it can happen in other cases too.
So not a slam dunk.
Nope.
What about the lungs?
Yeah, the lungs can tell us a lot. In drowning, they often get overinflated, like really filled up with fluid and air.
Okay.
And they take up a lot of space in the chest, sometimes even pushing on the heart.
So they would look different than normal lungs.
Yeah, they get this waterlogged appearance. They're heavy, spongy.
It's crazy to think that just by looking at the lungs,
Right.
you can get so much information.
It's pretty amazing. But again, even those lung changes can happen in other situations, like heart failure or certain types of pneumonia.
So you can't just jump to conclusions.
Exactly. You got to look at everything. The circumstances, was there water in the stomach? Even tiny things like microscopic evidence.
Microscopic evidence, like what?
Remember those diatoms we talked about?
Right, the tiny algae.
Yeah. So those can get into the lungs when someone drowns, and if they're still alive, those diatoms can actually travel into the bloodstream and end up in other organs.
Oh.
So if you find diatoms in the brain, or kidneys, for example, that can be a sign that they were alive when they went in the water.
That's incredible. It's like a tiny little clue that tells a big story.
It is. But remember, diatoms are everywhere, so you have to be careful about interpreting that evidence.
So we've talked about froth, overinflated lungs, diatoms. It's a lot to take in.
It is. Drowning is way more complicated than it seems.
It really is.
There's no easy answer, no one test that tells the whole story. It's about looking at everything and putting the pieces together.
It's like being a detective.
Exactly. You gotta think like a detective. And sometimes the tiniest clues can be the most important. But that's a story for another deep dive.
All right, listeners, we've gone deep into drowning. We've explored the controversies of restraint asphyxia. We've even talked about the dangers of positional asphyxia.
Asphyxia is a fascinating and complex subject,
It really is.
and each case presents its own unique challenges.
But we're not done yet. We'll be back in part 3 to wrap things up and explore some even more fascinating aspects of asphyxia. All right, deep divers, welcome back for the final part of our asphyxia exploration. We've covered a lot of ground already. Drowning, positional asphyxia, restraint asphyxia. It's amazing how many ways there are to, well, cut off oxygen to the body.
And how challenging it can be to determine exactly what happened.
Exactly. So what's left to explore? What's the final frontier in our asphyxia adventure?
Well, let's circle back to something we touched on earlier, suffocation.
Okay, suffocation. Seems pretty straightforward, right?
You'd think so. Essentially, it's being deprived of air.
Right, like being smothered with a pillow or trapped in a room with no oxygen.
Exactly. But even within this seemingly simple category, there are nuances that can make things tricky for investigators.
Really? Like what? I mean, if you find someone buried alive, wouldn't it be obvious that they suffocated?
You would think so, but the challenge is differentiating suffocation from other forms of asphyxia, like strangulation or choking.
Oh, right, because they all ultimately lead to oxygen deprivation.
Precisely. So the signs can be similar.
Okay, so how do you tell the difference? What are forensic pathologists looking for?
It's all about those subtle clues that point to one mechanism over another. For example, in suffocation cases, you often won't see the classic signs of strangulation, like ligature marks or fingertip bruises.
So what do you look for instead?
You focus on the environment.
So the scene becomes really important.
Absolutely. Are there signs of a confined space? Was there a struggle? Think about those cases where someone is found buried alive. You'd look for signs of disturbed soil, maybe overturned furniture if they were trapped in a room.
It's like the environment itself is telling a story.
Exactly. And sometimes the environment provides the most compelling evidence. Think about cases of smothering where a pillow or a plastic bag is used.
Right. No obvious injuries, but the object is right there at the scene.
Exactly. But what if the object is removed? What if the perpetrator takes the pillow away?
That would make it harder to prove, wouldn't it?
It certainly makes things more challenging, but there might still be subtle clues left behind.
Like what?
Think about the skin on the face. It's so delicate. If someone is smothered with a pillow, for example, you might find faint impressions of the fabric, maybe even the stitching pattern.
Wow, that's incredible. It's like the tiniest details can reveal the truth.
It's all about observation, noticing those subtle signs that most people would miss.
It's amazing what forensic science can do.
It is. It's a testament to the dedication of those who worked tirelessly to uncover the truth, no matter how well hidden it might be.
Well, I think we've officially explored every nook and cranny of asphyxia. From drowning to strangulation to suffocation, we've covered it all.
And we've seen that it's a complex and fascinating subject.
Absolutely. So much more to it than meets the eye.
It's a reminder that death, even when it seems straightforward, can be shrouded in mystery.
Well said. A big thank you to our expert for guiding us through this intricate and, let's be honest, sometimes unsettling world.
It's been my pleasure. Always happy to delve into the mysteries of forensic science.
And to our listeners, thank you for joining us on this deep dive. We'll be back soon with another exploration into the fascinating world of forensic science. Until then, stay curious.